Hello. So, let's discuss another problem on DFS known as a transitive closure of the graph using DFS. So, given a directed graph, find out if a vertex V is visible from the vertex U or the vertex pair U, V in the given graph. Here, the reachable means that there is a path from U to V. The reachability matrix is called transitive closure. So for example, consider a graph and transitive closure of the average is equal to reachable 1, 2, 3 like this. So discuss earlier. So for that we have to create a graph, identity matrix, and list is. So this one is good. So application of DFS, we know detects a cycle in undirected graph. Detect cycle. So detecting cycle in a graph is a great question. So so document side. Okay. Detect the cycle in an undirected graph. So this one is pretty straightforward question. So you are given condition is that you are given in this text. So given conditions are as follows. Given what are given? So given as ADJ matrix. Okay. After that, representing the undirected graph, determine whether the graph contain a cycle or not. We have to determine. The cycle or loop. In another loop is there or not. A cycle is a path that start. In simple term, cycle means start is equal to end. Okay. So let's take an example. The input is given like this. So input is given like for identity matrix. ADJ list is given. Input form is equal to 1, 2. This means that 1 is 0 is connected to 1 and 2. Okay. After that 0 comma 2, this means that a one node is connected to 0 and 1 because it's undirected. There is no direction between the nodes. So after that there is given as 0 comma 1 comma 3. This means that 0 1 2 2 is connected to 1 0 and 3, and lastly the third is 2, simply 2. So this means that a third graph number third is connected to 2 only. So this is a pretty straightforward question. So is there is a graph cycle on in or not? So simply we see that the answer will be yes. Answer will be true. There is a graph between this. So how could we solve? So first of all, there is a technique. We have to traverse one node, the neighboring nodes and nodes. If we check starting is equal to n, then we have to return. If we already visited this minute, there is cycle present inside this. So there is two technique from the BFS and DFS. So Lieutenant, the idea is to use the DFS. When we start DFS from the node, we will visit its connected nodes, connected neighbor by one. If duration this traversal, if we reach a node that was already visited before, it indicates that might a cycle since we have back to the previous slow vertex. However, there is a one important catch in undirected graph. Every edge is bidirectional. The catch is the every edge is a bidirectional. This means that if there is a edge between U to V, there must be edge also between V to U. So while performing DFS from the U to go to V, from the V, we again see U as one of his neighbor. Since U is already visited, it might look like a cycle, but it is not. So keep in mind. To avoid these issues, so we can keep track of their parents, the node from which we reach the current DFS. So when we move from U to V, mark the parent as a V. Now, while checking the neighboring of the V, if a neighbor is not visited, we continue DFS. So let's write the code for the DFS. A cycle or not, a cycle or not. So document checking a cycle. So first of all, bool cycle, bool, mm, bool cycle or not. So we are given a 2D vector and adjacency list integer of known as ADJ. Okay, ADJ. Okay, so we have to determine the number of vertices. Determine how we, so int v is equal to ADJ dot ADJ dot size. Okay, after that marking all the vertices is not written. So first of all, start initializing that all the vertices are not visited. So we have to make a vector bool type is visited. So there must be a cycle. So before creating a visited array, when all the vertex is marked as a false. Okay. After marking all false, we traverse through all the vertex if it is marked or not. So for loop int I is equal to 0, v, I less than v, I plus plus. Okay. So if not visited of I, this means we have to run the DFS loop. If DFS is true, if this function return true, comma ADJ list, comma visited array, comma -1. The point initially starts with the -1. If this condition is true, we have to return true. There is a loop between this. So return loop. If this condition remain false, if all this condition remain false, this means we have to return false. Okay. So there must be code for the, we have to write code for the DFS. So how you determine? So simply bool DFS 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 int will be the adjacent vector, the next node. So v, like v, not as v, capital V, and the adjacency matrix. So vector of vector widget adj, and in vector of widget also define the boolean for the visited array. Okay, and the parent for this DFS steps we have to also define the parent because we is undirected case. In directed case, u is pointing to v and v pointing to u. So this is misjudged by as a loop. This is not. So we have to track the parents also. For visited array, for firstly mark visited of v is equal to true and recursively all the vertices of their adjacent. So for loop auto IT auto IT over adjacency matrix ADJ of V. Okay, and if it is not visited, if it is not visited of what IT, this means that we have to run the DFS loop. If no, if it true, DFS of IT ADJ list and visited, and now parent become the previous one. So parent become previous one which came earlier. So V. Okay. If condition is true, then return true. Okay. If condition true, return true. Otherwise, or else if condition if if condition satisfied. So after that else if IT is not is equal to parent, and if IT is not parent, then return true. Okay, already waited. If IT is not equal to parent, then return true. Otherwise, well, you are feel free to return false. So return. Okay. Simply find the number of nodes. After that, we have to make the Boolean array, and after we have to traverse all the nodes. If not weighted, call the DFS function. If DFS function return true, then return is a there is a cycle in this. For DFS function, we have to initialize the node, the starting nodes, identity matrix, and the visited array and parent. First of all, mark the nodes as true and run the for loop for their adjacent neighbor. If the neighbor is not visited, run the DFS. If it visited already, return true. If its parent, if its parent is not the IT, also return true. After that, if these conditions are not satisfied, return false. Okay, that's all for the detecting cycle in undirected graph.